Topology is an important branch of modern maths that we don't often hear much about. So what is topology, and what kind of things does it deal with? We all know what geometry is because it's taught in school. It's about shapes and sizes of things like triangles, circles, cylinders and so on. Topology is less familiar, but even children dabble in it. Whenever they play with modelling clay, they're moulding things and changing one shape into another, and that's what topology is all about. It has to do with the properties of things that remain the same even when you twist and stretch them. For instance, to a topologist, a ball of Play-Doh and a plate are pretty much the same thing. That's because the Play-Doh can be flattened out into the shape of a plate, or a plate-shaped piece of Play-Doh can be rolled into a ball. A plate and a cup, on the other hand, are very different in the eyes of a topologist for the simple reason that the cup has a handle with a hole in it. Think about some items of bakery: a bun, a bagel and a pretzel. The bun can't be deformed into the bagel without tearing it and making a hole. To a topologist, the term hole has a specific meaning. A hole that's dug in the ground doesn't count as a topological hole, whereas a hole in a bagel does because it goes all the way through. In the case of a pretzel, you can see that it has several holes, so again, it's topologically distinct from the bun and the bagel. Roughly speaking, in topology, the number of holes in a shape is referred to as its genus. A bun has genus 0, a bagel genus 1, and so on. Now let's go back in time and look at one of the first mathematical studies in topology, which was carried out by the German mathematician August Ferdinand Mobius. The so-called Mobius band is like an ordinary cylindrical band, except it has a half twist. It looks simple, but it's got some strange properties. An ordinary band has two sides, an inside and an outside. But in the case of the Mobius band, if you start at any point thinking this is the outside and trace your finger along the surface, you'll get to the inside without having to cross over the edge. So a Mobius band has only one side. The number of sides that a shape has, like the number of holes, is a topological property. What happens if you cut a Mobius band in half? Of course, if you cut an ordinary band in half, you get two separate cylindrical bands. With a Mobius band, it's a lot less obvious what the outcome will be. The easiest way to find out is just to do it. And the result? We get a single band with two twists in it. What happens if you cut a Mobius band in half and then in half again? Or what happens if you cut a Mobius band in thirds? I'll leave it to you to experiment. The final thing I want to mention, and another interesting area of topology, is how things link together. The example I'll use involves three interlocking rings. These are connected in such a way that if you remove one of them, the other two will fall apart. In other words, no two of them are joined together. It's only when all three are combined that they interlock. They're known as Borromean rings, after a medieval Italian family. The family of Borromeo used the pattern in its coat of arms. But the origin of the rings goes back much further. They can be found, for instance, in the art of the Vikings. I hope you've enjoyed this little excursion into the world of topology. In a second video on the subject, we'll be crossing bridges and colouring maps, among other things. So join me for that, and don't forget to subscribe if you haven't already. Thanks for watching, and see you again soon.